Coming to container orchestration, one of the things that we have seen is that there has been a fundamental shift from traditional infrastructure to cloud-native paradigms that in turn have been driving innovation and efficiency. The containerization revolution has been also at the forefront of the revolution, where one needs to understand the pivotal role of containers in modern application development and deployment, which is where this diagram, which is, I think, provides a good understanding of how containers fit in. Because earlier we had physical machines sitting on the data center, and that is where we used to deploy a lot of the applications, and they would run out there. Then came virtual machines, where on a VM we would have a hypervisor, and on the hypervisor there would be further VMs that one could have, and one VM could be of Windows, one VM could be of Linux. So you could kind of have multiple applications sitting on the VM and provide clear isolation on how the application, without providing any interaction between the two applications. So you would have the guest OS, which is the virtual machine. It could be Windows or Linux. And then you would have the binaries required for running the application, and then the application would be installed. Now, this was good. And a lot of applications still work on VMs, and they are suited to work on VMs. It's not that everything is good for containers, but that is a discussion for another topic. Feel free to put in a comment if you want to have, you want me to kind of create that comparison of when to use virtual machines and when to use containers. But you would have heard a lot of times during your development, it works on my machine. It doesn't work on your machine. So that is something that we have constantly heard, especially in the software development cycle, that something works at my machine while it doesn't work at their machine. And the same thing happens when we start promoting code from a development server VM to a QA environment, to UAT, to eventually to production. So that is where the cycle continues, because the reason for that is because some binaries could be there in a particular VM, which are missing as part of the package, and that in turn is causing the application issues. The container provides a little bit of abstraction on that segment. Now, this is where you see over here, this picture to the right, which provides the containers overview, where you have a host operating system. And on the host operating system, you just have a container engine, which provides little better resource usage of the VM, of the virtual machine that could be required. And there you would have, like in a container, you would have a particular binaries. It could be a Linux binary. It could be the application dependent libraries that are required. And then you have the application. And this container is what is pushed to a repository, which would be used for building for your pipeline in subsequent environments. Thus, it minimizes the chances of the scenario that it works on this machine, but doesn't work on this machine. And then as well as like it works on one environment and not on the other environment. If we could kind of come down to the microservices architecture, which essentially is that the smallest effort of task, you could containerize it and provide more granular orchestration between the services. Now, this is where we have how the traditional infrastructure that we have been working towards and how they have been kind of moving, we have been moving out of. That is, we have moved from traditional infrastructure to virtualization and then eventually to containers. And we're kind of moving into the cloud native paradigm. So that is a journey that we have been having across the software lifecycle. And this is where the AWS Container Services, they provide the way for seamless adoption of cloud native practices. And now, why orchestration matters? Containerization has revolutionized the way we develop, deploy, and manage applications. It brings several benefits, including enhanced portability, scalability, and resource efficiency. As applications become more complex, effective orchestration becomes crucial to streamline deployment and management processes. Now, you would be asking, why should I really have orchestration? I'm fine with my application running on a VM. So why does it matter to have orchestration in place? So orchestration, it simplifies the deployment and scaling of containerized applications. It manages the lifecycle of containers, ensuring that they run efficiently and reliably. Orchestration also enables seamless communication between containers and automates essential tasks. This is where the whole framework of the container orchestration comes into picture, so that you as the developer can just focus on development while the operation person can focus, and a lot of the complexity is taken out of that and moved to the orchestration system over here. So what are the AWS solutions for orchestration? AWS provides a lot of robust solutions for container orchestration. So, but for the sake of this presentation, and there have been new services that keep coming out, we are just going to focus on two ones, which are the most matured, and a lot of customers, we have seen a lot of customer adoption for these two services primarily. One is the AWS ECS service. That's also called Elastic Container Service. And the other one is called the EKS service, or Elastic Kubernetes service. Please like, subscribe, share the video. Please contact us for any of your cloud requirements or cloud consulting requirements. We have decades of experience in cloud, and we can definitely help your organization take the right step in cloud. With that, thank you, and see you in the next video.